All right, hello. I'm here to talk about GoCV. I built a toy project with it because I was interested in it based on some experiences that I've had. Let's get into it. This is the project that I've been working on. I have a command or a CMD directory with a couple of executables. One is cli. Um, the other is the web server. Um, what this app does is, this is the web app. You can see it here. You can select a Haystack image, which in this case is a picture of my web browser opened to a music video of the K-pop group IVE. And then you can select a needle image. The needle image is it's a selection inside of the haystack. It's supposed to be an exact subsection of the haystack. And then you hit submit, and it'll go and find the needle in the haystack. So you can see that it says, hey, here's the needle that you gave me. Here's your haystack, and this blue rectangle is me finding your image. It's achieving that with OpenCV. I don't know anything about OpenCV or like machine learning or neural networks. I don't know any of that shit. I'm just a web developer. But I was able to get it to do this. There's an example in GoCV that does this already. I'll show you what it produces. I was able to get it to draw the little rectangle here. So we can see some other things that I had to go find. I had to look for this picture of text king, and I found it on the right hand side. I had to look for subscribers, which is almost the same color as the background, but it was able to find it down here. I am is text in the video title. We've seen that already. This is another person. It found her. This is a different haystack. It was able to find this small Lego in this pile of Legos. Here's another Lego in the pile of Legos. It was able to find that. And here's another Lego. Okay. This project is organized the same way as the video I made a couple days ago entitled 1,000 Lines of Golang. So in this, I'm in the package directory or PKG directory, and there's this available function called FindNeedle. So what do? We load up our haystack image data. We load up our needle image data. And this is using GoCV. We construct a sift, whatever that is. We're making these mats all over the place. A mat is like it's a data structure that is really common in OpenCV, and GoCV gives us access to a wrapper around it. We say detect and compute to build some information about our needle. We call the same method for the haystack. I construct a flan matcher. The example in GoCV, if you look in the CMD directory, I think it's called feature matching or something like that. It uses a brute force matcher, but I wanted to use a flan matcher because I did this Googling and I found this blog post. If you Google needle and haystack Python OpenCV, you'll find this. And they use what they call a flan matcher. Yeah, here it is. So that's why I use this. GoCV allows you to call it, although you can't pass all of these all the options to it that is shown here in this blog post. So anyways, I construct that. I say, hey, give me my match or my matches. It'll give me an array of matches, and I iterate over them. I try to calculate the matches that are good using this test. This test is a mystery to me. I don't know why we do it, but if you don't do it, you get some false positives. And I'll show you like what I think these matches visually are in a second. So after you run this filter, we get an array of what I'm calling the good matches. I call this match render, but I don't actually use the result. If I go to the implementation of match render, it really calls this GoCV function called draw matches. So let's take a look at what that does. I'm going to use the CLI here. So this is a CLI. It's showing me the blue rectangle. That's great. But if I make use of this match render result, if I return that instead of what I'm actually returning, I can show you what it does and what I think the matches are. I get link errors running this on my Mac. I don't know why. I tried fixing the problem and I couldn't fix it. Oh, don't say that. I think I have to not deallocate this. The caller has to deallocate it. Okay, so on the top left, it's hard to see, but there's the needle image, and then beside it is the haystack. There are all these circles. I believe the circles are key points, and then there are these green lines. These are going from the needle to the haystack, and it's trying to tell what it's saying, I think, is that, hey, I found all these interesting points on the needle, and here is where I think these points are in the haystack. So this is what is produced by the draw matches GoCV function. I'm gonna go back, or have this go back to the way it was, so we can see the blue rectangle, and I'll talk a little bit about how I got the blue rectangle. Okay, it's back. Okay, so after, I don't use this with the current compilation of the code. The reason it's not giving me a compiler error is because I call close on this. But I do clone my haystack, and then I say calc origin, please, and I use that origin to draw a blue rectangle here. Rectangle is coming from GoCV. This rect is actually coming from the image Golang library, so there's some cooperation going on there. What does calc origin do? Calc origin it goes over all of the good points, and it says, okay, for every good point, I should be able to determine where the origin of this blue rectangle would be. That would be when I say origin, I mean the top left. That's how I'm able to draw this. If I find a key point where my mouse is, I should be able to determine, oh, the origin would be up here. And when I say find a key point, I mean, you remember those green lines that we saw earlier? If I find a green line pointing to something on the haystack over here where my mouse is, that implies that the origin of the blue rectangle would be up here. Every match implies a certain origin. So what I do is, forget this loop for a second. I say, if I don't recognize the origin, then add it to my list of origins. I'm building an array of origins here. And keep track of the number of times I've seen that origin, set it to 0 at first, and then increment it for every good point or for every good match. A match includes both a key point in the needle and a key point in the haystack. Okay, now back to this. What I do before I decide that I've never seen the origin before is I go through all of my existing origins and I do a tolerance check using an epsilon to say, hey, have I seen this before? Is it close enough to an origin that I've seen before? And if so, I capture its index and I say, hey, I recognize this. I could probably, if I were smart, I could probably get rid of this Boolean, but whatever. And my epsilon is like, you would expect it to be a fraction given that I'm using the term epsilon. But 1 works. Like I'm saying if the x coordinates, for example, are less than 1 unit apart, then call it the same origin. So then I do another test. I say, hey, if I have some origins and the number of good points is, or I should say the good matches, if the number of good matches is much higher than the number of origins that I found, then there's a good chance that I've actually located the needle. And in that case, I just find the most popular origin. That's all this is doing. It's a typical find the most popular element in an array loop. And then I construct a tuple. I have my x coordinate, y coordinate, width and height of a rectangle, and then I return that. If I didn't find an origin, then I return nil. So with that, I'm able to get back and go ahead and draw the rectangle if I found an origin. Perhaps I should say calc rectangle coordinates instead of calc origin, but whatever. That's all the GoCV code that is in this project. So now let's talk about building OpenCV4 on your Linux machine. On OS X, you can kind of follow the directions on the website. You can follow the directions on the website and you can use Homebrew. But on Linux, it's a little bit of a different story. I've got a Docker. I've got Ubuntu on a Docker image here, so I'm going to launch that. This is jammy. This is 22. I'm going to mix in an update. And if you've got Jammy installed somewhere, you probably don't have to go through these first steps because your installation is probably more developed than this. I'm going to install git, make, sudo, and Golang. That'll take a minute or two. After I do that, I'm going to go ahead and clone the GoCV repo. This is, you might say, redundant because if I'm compiling against GoCV, I shouldn't have to download it. Go get will do that for me, right? Well, I wasn't able to get that to work. My code, of course, compiles, but to install OpenCV, I wasn't able to run that fast. I had to slow down and walk. So that's why I'm doing this. I don't know of a way to tell GoGet to just download your project's dependencies. It tries to build all the time. And yeah, like maybe if I were to retry this, I would be able to just use the installation location of the GoCV library as referenced in my source code. I mean, if you just look at the right-hand side, you can see that I'm referencing this project here. If I could just find out like where they were installed, maybe I'd be able to make use of that. But I gave up and I just cloned the repo. So like in my case, I made a vendor directory and I put it in there. I usually make a vendor directory and put my vendor source code in there if I can help it, to keep it separate from the things that I'm working on that are mine. So here's my clone. I get into the directory and I switch to the dev branch. I'm on the dev branch because I submitted a PR today that fixes a misnamed package for Jammy. And then you can do make install. This command is going to download and build OpenCV4. It takes a half an hour to run. I'm just showing you that it gets kicked off, so I'm going to stop it. But that's really, like, when it finishes, it'll run, like, I believe it runs the version command inside of GoCV, and it prints out the version of GoCV, and it prints out the version of OpenCV4, which as of this video's published time is 4.7. So that's installing OpenCV, and then once that's there, your project can compile. Like what I have on the right, it'll start compiling. All right. So the rest, that's pretty much the end of the video. I've honored the title of this video. The rest of what I'm going to talk about doesn't really have anything to do with GoCV specifically. So I was going to just talk about the web server code. I'm just going to talk about other stuff I learned, other stuff, just things that I didn't know before. So if we go into my web server code, there are some neat things I found out. Like a lot as you can see in my previous video, but you can actually serve static files using this technique. You just say, hey, where are my files at? And you say, hey, I want incoming requests that start with this prefix to go to this static file server. I've got 2 of them mounted here. When making a request, this is when someone's clicked the submit button on the website. So when they've selected these variables and clicked submit, I'm using this store file. I just want to show how you get your file data out of a request. You use this thing called form file. You get a file back, and then you can call read all on that. And then with my bytes, I just write them to a file. And I'm using a UUID to make all requests uniques, and I also use that in the storage location on the hard drive for my files. I have this little write internal server error helper that helps me respond to 500 errors. It's just this HTTP error thing right here. I think this means 500. It's like an enum. This is kind of cool. When I go to get the recent results, like for this listing, I actually issue, this is not like, I hate using backticks even when I'm in a shell language or scripting language. I like to use something that's going to allow me to elegantly capture standard out and standard error. When I would do this in Ruby, I would try to use something elaborate so that I could mock it with RSpec tools, which you can't really do with backticks. But this is how you do it. You construct a command. The command gives you, it's like a struct that you can go read about. You say start, you say wait, and then what I'm doing is I'm reading all of the output. I'm splitting on new lines, and I'm doing a regex match to find the UUID of the file that I'm looking for. I'm looking for all files in this parent directory using find that end with JSON. There should be one per UUID directory. And then with that, I go and open up my data JSON file, or excuse me, I just stat it. When I stat it, that's how I get this information on the right-hand side. I can get when it was created. I guess it's the mod time, but since I only write once, it works as the creation time. So yeah, I do that. I go ahead and reiterate over all of the things I built to get a pretty time, which is just a formatted time string. And then I do a sort. This is a descending sort, so I'm using what you do is you import the sort library and you call slice. You pass an anonymous function or some function that returns a bool. I think you return true if it's negative to achieve an ascending sort. So I would use before here if I wanted to do an ascending sort, but since I want a descending sort, I use after. I just compared the two mod times of I and j from my slice, and that's why these are descending, which you can see here. So that's the web server. When testing this, I was looking for memory leaks. I made this little curl script. This is how you do a post to an endpoint with different binary params passed in, and you have to give it this header so that it knows I think this might be redundant given that I'm using -F, but I threw this in here anyway. Let's talk build tags. In my web server, there is this profiling Go source file. I have a build tag that's saying, hey, only include this source file if the matprofile tag is turned on. You can go Google the details of these build tags, but I'm using it here. If it is here, then I include this library. I'd like to show you this. I have a debug web server that actually uses the tags option here. Normally I build a web server without that, but if I want to debug it, I can do this. So let's see that in action. Oh, excuse me. So it's passing in the tags. That means that this is going to be pulled in, and this will add a handler to my web server. I have a little binary here, and if I go to this guy, I get this. There's this little like handler that can tell me about my my project, and if I were to like forget to deallocate some of my mats, which was a problem for me. Like I'm gonna go upload an image, and that goes in, and if I refresh this, that's still 0. But if I go into the source code to my FindNeedle and I say, let's see. Let's go ahead and not deallocate my mask for the haystack that I pass in here. That's a mat, so it has to be deallocated. But if I take that out and I rebuild this, I should have included this earlier in the video since it's a GoCV thing. But oh well. I'm going to go back here. We can see that this is 0. I'm going to do another search. Okay. Oh, shit. You're not mad? How come you're not mad? Oh, I know why. I made the wrong project, or the wrong build target. It's supposed to get mad. That's the whole point of this. Like, you're supposed to find, oh, my web server, it's leaking mats, help me. So you come here, okay, fine, it says 0. Let's try this again. There it is. So we've leaked a mat, and it'll actually tell you, hey, in FindNeedle 141, you allocated a mat. Here we are, and you didn't deallocate it. So it caught us, and you can see the total is 1. If I invoke that FindNeedle again, I'm going to have another mat that I haven't deallocated. Now the total is 2. So this little profile guy is helpful for finding if you're leaking mats. And I guess one more comment about the build tags. To make them work, I had to build in a certain way. I have to say, hey, go ahead and build this location. If you say like something like this, like, hey, build all the source files in this, and you try to get away with that, it's not going to give it. Hold on a second. I could have sworn this does not work. All right, well, I thought that you had to do it this way. Like to just pass in the directory that's going to hold your package that you're trying to build, the one that's holding main. I was messing around with this earlier, and when I was passing in the Go source files, I was getting errors. It was complaining to me about double definitions. So I think that if I'm going to use tags in the future, that I have to build my executables in this fashion instead of saying, hey, go find all the source files. I think that leads to trouble, but obviously I can't demonstrate it here. I'm not able to for some reason. Okay, and I was just gonna like back up a bit and just comment on some things I noticed today. Like I as I may have mentioned, I submitted a PR today to the GoCV project just to fix a misnamed dependency on Ubuntu Jammy. And I was there and I was looking at other people who were, creating issues and creating PRs. And I was seeing things like I saw someone who had made a PR, but they were trying to merge into the wrong branch. Like there are 2 paradigms I'm aware of that for branching strategies. One is trunk-based development, which is new, and the other is feature-based branches, which is old. And you would, if you're gonna make a PR, wouldn't you want to find out, like, hey, what paradigm is this project using, so that I know to have my PR go to the correct branch? But people weren't doing that. They were just trying to publish their changes right into the production branch of this project, or at least one person was. More than one person was. There were other issues where they were trying to fix this dependency problem for Jammy. Someone was trying to do it, but they were disregarding all the previous LTS Ubuntu releases that would not work. with this dependency rename, or at least that should use the old dependency, because they don't have this problem. So why would we like make a change that would break Bionic, which is Ubuntu 18, or Focal, which is Ubuntu 20? Like, wouldn't you want to pay attention to that? What about the Debian distro Bullseye? Like, that's still using the old dependency. So why would you change that just so that Jammy could work? Like, wouldn't you want to worry about backwards compatibility? But I didn't see, like, at least one person wasn't worried about that. And you know, I've been programming in Ruby for the last 13 years, and I'm trying to get my feet wet with Golang, and I come here and I see people doing this, and it just makes me wonder what the fuck is going on. Like, I think that Golang is the superior language in Ruby, and I come here and I see people doing these things. It makes it worse when I think that this is the OpenCV wrapper for Golang. Like, OpenCV computer vision is a really hot property. It's supposed to be a really big deal. Wouldn't you want to bring a really elevated level of care to this project if you're going to work on it? But people were still making the mistakes that I mentioned, even though this is the Golang OpenCV wrapper. So I just found that to be kind of sad. It just reminds me that in this industry there are people who really care about what they're doing, and then there are others that are just getting by. And that discrepancy is mysterious to me. What a range of commitment you observe when you go to see people in this industry. I guess I could have toggled that earlier. Anyways, so that's my GoCV video.